Thank you for joining us today. I'm pleased to be here with Rob Travis from Cascade Energy, who will be talking about energy management information systems. Rob, would you please move to the next slide? I'd like to take a moment to thank our Seventh Wave members for making today's presentation possible. We are deeply grateful for their support of our online education. And now I'll turn it over to you, Rob.
Thank you. Today we're going to be talking about energy management information systems. The first thing I want to do is define what an energy management information system is. There's a lot of different acronyms out in the industry right now. We've got energy management systems, we've got building automation systems, and a lot of them have similar functions and characteristics, but in this particular case we're going to talk about energy management information systems. Wikipedia, interestingly, has 5 different definitions for an energy management information system, so this is just one definition. But in my mind, it's the best definition for what we're trying to convey, and it's a performance management system that enables individuals and organizations to plan, make decisions, and take effective action to manage energy use and cost. So what exactly does an energy management system consist of? Well, it gathers energy data, number one, gathers activity data, which could be either production, could be operations, schedules. It gathers energy drivers such as weather and other energy drivers at the facility. And then it analyzes the data, and it displays and reports on the performance. Why do we want to do this? Well, we want to be able to identify good and poor performance. We want to be able to share and promote best practices throughout the company. And we want to be able to justify and measure energy projects and the resulting savings. One of the quotes that I like to use here is, anything that is measured and watched improves. And that's kind of the nature of an energy management information system. This was a quote from Bob Parsons, founder of GoDaddy. And the basic layout of an energy management information system is, first of all, we start with the data. So over on the left here, we can see a couple different data sources. We've got our electric meter, we've got the weather channel data, we've got a gas meter, we've got production data, we've got some sub-metering. We want to be able to collect all the relevant data that we need. And then we're going to take that and acquire and store it somewhere, whether it's on a server or up in the cloud. And then we want to be able to take that data, analyze it, be able to see what type of information is going to be the most useful, then share that out with everybody in the organization and report it out so we can make some good decisions moving forward. The core features of an energy management system is, number one, data visualization. We want to take interval data from the different meters, so from our electrical meter, gas meter, water meter, and also want to take a look to see if sub-metering certain pieces of equipment would be of value. If we've got very high energy intensive pieces of equipment, say compressed air, refrigeration compressors, whatever the case may be, some of those would lend value to be able to sub-meter those and see how they operate in conjunction with the overall energy picture of the facility. Other features of the EMIS system is benchmarking. We want to be able to do internal benchmarking, see how our facility is comparing against ourselves. We want to be able to look at historical data, see how the energy today compares to how the energy was last week, last month, and last year. And then we also can benchmark externally. We can see how our facility compares with other facilities in the organization, or we can take a look to see how it compares with our competitors. Other core features is using cost data, being able to incorporate our electrical cost, the energy cost, demand cost, be able to generate reports and push the reports with the appropriate information to the stakeholders that are able to make decisions. We can use it to do project management while we're looking at for energy projects. And then we can also use it for measurement and verification of energy savings. So weather, occupancy, production, and then also using it for predictive analysis to be able to predict what our energy use should be based on the energy drivers of our facility and our historical energy consumption. So it's important to note that an EMIS, what it is and maybe more importantly what it is not. An EMIS is a process tool. It is not a widget, it is not a black box solution, it is a process that's part of a greater energy management program. An EMIS enables savings, but it doesn't actually generate savings. It gives you the tools and the information you need to be able to make decisions to save energy. And it's best used within an energy management program. So it's one element of a greater energy management program at your facility. The energy savings through an EMIS come through improved visibility and understanding of the energy use. Instead of just looking at your utility bill and seeing you used X number of kilowatt hours with a demand charge of Y, this actually gives you the data on a more incremental basis so you can see day by day, hour by hour, and minute by minute where your energy is going, and with that you can look for opportunities on how to reduce that. It allows you to identify new energy efficiency opportunities. You can see where energy use is higher in certain subsystems or certain operations, maybe certain different production lines, and make some decisions on how to move forward. It increases accountability and performance tracking. So your operators, engineers, technicians that are operating the systems, they're the ones that are going to have their hands on the systems and are really going to be the ones that are dictating the energy use of a lot of the major subsystems. So being able to add performance tracking for them and also holding them accountable to certain energy reduction goals is one of the criteria for an energy management system. And then lastly, benchmarking processes or facilities across the organization. Being able to set goal lines and be able to strive to meet those goals in order to reduce our energy use. One clarification I wanted to make, going back to the different acronyms that are on the market, an EMIS versus a building automation system, they are not the same thing. They may have some elements that are similar. There's definitely some crossover between the two different platforms. But a building automation system is the automatic centralized control of a building's heating, ventilation, air conditioning, lighting, and other systems. The two most important points to differentiate the two is that a BAS controls things, and EMIS monitors and reports. As I mentioned, there is some overlap. There are some building automation systems out there that have elements and functions of an EMIS, but them by themselves generally don't constitute an EMIS. So how do we reduce energy costs? Well, as I mentioned before, the EMIS system is one integral part of a much larger energy management program at your facility. And in this chart we show right here, it's the very first thing that you need to put in place in order to start your energy management program. So step number one is being able to measure and track our energy use. All the steps within that blue column there are all the different pieces that go into creating a successful EMIS. Once that's in place, then we can go on to the other steps throughout the process, which are the steps that really are going to help us save energy down the road. So the next step there is to train and certify our employees, making sure that they have a good understanding of the energy saving principles and how that applies to their job functions. Then we take that and move into phase 3, which is pursuing low-cost, no-cost energy efficiency opportunities. We always want to go after the low-hanging fruit first, the opportunities that don't cost very much or cost very little to implement. Once we've achieved all those, then let's start looking at some of those capital projects. Look for the ones with the better ROIs, or 2, 3, 4-year ROIs, and start implementing those at the facility. And then lastly, the last piece of this energy management program is to look at optimizing your energy rates, talking to your utility, seeing if there's a better rate structure that you may qualify for that would result in lower cost. But this all starts with having the platform that can measure and analyze your energy. So meaningful measurement, if we're comparing what you may have now with just looking at energy bills compared to an EMIS, is that the energy bills, your utility bills, going to give you a post-mortem look at what happened at your facility. A lot of times the energy bills come to you a month, 2 months after the fact, and you can take a look at it and say, hey, our energy increased 10%. Well, what happened? We don't know what day that happened on. We know somewhere during the month our energy use went up. As it was because it's a warmer month, did our production increase? It's very hard to identify what caused any changes in your energy use when you look at just the energy bill. It does not tell you what is wrong, when it happened, how to fix it, and also what is at stake. So remember, you don't measure savings, you measure a change in trajectory. So here's an example. Looking at just a utility bill where it shows you that you've used a certain amount of kilowatt hours and you're at a certain peak demand. In this situation right here, we had a facility that had really high on-peak rates. And so they implemented a really smart strategy of dropping off some of their load during these peak periods, and so they'd qualify for lower rates during those periods. What they didn't understand is the way their system was operating wasn't perfectly aligned with the utility on-peak, off-peak rate structure. So in the graph right here, between the dotted lines, that was the on-peak period the utility was charging them. Well, the facility had the right concept. They were dropping their load off in an attempt to meet those, that on-peak period, but they just didn't have it lined up quite right. So they were actually not saving any energy, and more appropriately, any cost, because they didn't have this interval data to see exactly where the energy cost was coming from. By getting the energy data from this EMIS system, they're able to then shift their operation and get that load shedding to match up with the utility rate structure. So what constitutes an EMIS system? Well, it can actually have a myriad of different elements. So what I'm going to talk about right here is just the most basic system, but it can become more and more complex depending on how many inputs you want to pull into it and where those inputs are coming from. So as the very basic core, you're going to be able to take a pulse output from a utility meter. So looking at electric meter, a gas meter, water's becoming a more valuable resource, so water meters as well. Taking whatever component you want to and pulling it into a data acquisition unit. So you can see on the graph right here, we've got two different meters coming into a data acquisition center. Now, in order to do that, we've got to make sure that the electrical meters, the utility meters, have a pulse output on it. A lot of the newer meters have that. If they don't have it, you can always contact your utility, and for a minimal fee, generally in the $500 to $1,000 price range, they're able to install a pulse output. But once you have a pulse output on your utility meter, that data can be sent to this data acquisition center. The data acquisition center then can communicate via cellular communication to your EMIS system software platform. So this takes the data and uploads it into your system software platform. We also have production data. Production data can be pulled into the system through a variety of ways. We can manually input it just through manual data entry. There you can have automatic push reports from your production software system, or if you've got a SCADA system of some sort. And then we want to pull in weather data, because weather is also going to be a big energy contributing factor in most systems. And that can usually be done automatically. So all that information gets pulled into your energy management information system. And from there, you can look at any of the real-time data. You can view it in a whole host of different ways, depending on which ways are most applicable and most meaningful to you. And then the reports can be automatically generated, and that pushes the appropriate material to the appropriate stakeholders. So maybe going up to the management, they want to see, as far as just maybe a % savings, maybe more on the incremental level, they want to be able to see what your particular system is doing day after day. But those reports can be automatically generated, or we can just look at it real time. So the analytics, we've talked about capturing and sharing the data. We've got context on performance, and then that should give us insight on what to do. So a couple different ways we can analyze the data. The two major ways is we can look at key performance indicators, which are KPIs, or we can create a predictive model. So I'm going to talk about both of them here briefly. For our key performance indicators, this is normalizing the energy use to some other variable. So the most common thing to do, say if you've got a production facility, is taking your energy use and dividing it by your pounds of production, how many widgets you produced, how many pounds you produced. So you've got kilowatt hours per pound or per number of widgets. You can benchmark that among similar facilities. If you've got several facilities throughout the country that are doing the same thing, it's a very good benchmarking tool. But one of the cons is it's a false indicator with big changes. If you've got a big change in your operations, if you've had an expansion, maybe you've done a big energy project, maybe your production level really drops off, things like that won't show up, or I'll give you false readings in your KPI and may make the facility look like it's doing better or worse than what it really is. So it's got some good pros. It's a very easy thing you can set up, but you just have to be wary of the limitations with that as well. The second part here is building a predictive energy model. This, in most cases, is going to be a lot more accurate way to predict your energy savings and then be able to track your energy savings after that. So in order to do a predictive energy model, it requires a couple different things. Number one, we want to be able to build the model to represent the historical correlation between energy and key variables. So the first thing you want to do is be able to identify the key variables that drive the energy use at your facility. Could be production, probably weather is going to be a component, whether dry bulb, wet bulb. your operations, operating schedules, and then what else? What else is an energy driver at your system? Being able to identify those and then be able to see which ones have an effect on your energy use that can be pulled into this predictive analysis. And a predictive analysis simply is a mathematical regression that can, once it pulls in all those variables, it assigns coefficients to the variables, so it predicts exactly how much energy your facility should be using based on the levels of those drivers. So an example of that, without getting into too much detail of the math, this chart right here shows us the actual energy use and a predictive mathematical model that was created for this particular facility. So you can see on the green line is our actual kilowatt hours measured. You can see it increases during the day, decreases during the evening over the course of several days here. The mathematical model that was created to predict the energy use is the blue line, and it's really hard to see because the blue line actually lines up really closely with the green line. So this is a good indication that the mathematical model to predict the energy use is a really good model because it's predicting it very accurately. So with the predictive model, it takes into account things that normally, if you look at energy and say your energy use went up 10% this month, it's really easy to say, well, it was warmer this month, so that's why my energy went up. Or we had an increase in orders, so that's why my energy went up. This model takes that all into account, and it'll tell you, are you really saving energy or not, because that's all built into it. So maybe a little bit better graphic to show you here is that in this particular example, we've got the start of an energy program with an EMIS application. And as it started here, you can see that the green line is our calculated energy use, the light green line, I'm sorry, and maybe that's a light blue line. And then our darker blue line is the actual energy use. So they started the program at the white dot or the yellow dotted line, and then you can see on this lower green line all the different actions that correlated to their reduction in energy use. So again, your EMIS by itself is not going to reduce your energy use. It's having the EMIS in place and doing actions accordingly that reduce your energy use that kind of pull it all together, and you can give you the holistic approach to reducing your energy. So right here, step number one, they reduce their pressure. Maybe this is a compressed air system. They reduce their pressure. And you can see the actual energy use started to dive off and get a little bit lower. The difference between our expected energy and our actual energy is our energy savings. Step number two, they improved the startup procedure of the equipment. When that happened, well, the energy savings increased. Next thing it is tuned in VFD settings, and again another increase in energy. And then they did a leak repair, which increased it even more. So in this particular way, we can actually correlate actions that we've done and see exactly how much energy is being saved based on those actions. Now this is a really nice graph because it shows all really good positive actions, but we're all human and we don't always do things right. So this can also track bad actions. Maybe we had a really good idea and said, hey, I'm going to do this. We implement it, and all of a sudden we see that our actual energy use is starting to increase and our savings is decreasing. Well, maybe that wasn't such a great idea, and we can actually go back and reverse that. But we wouldn't have known that unless we had this data to actually take a look at. So here's another graph that we can take a look at. This shows, again, the actual energy use in green. Our blue energy uses are a predicted model. And the red shaded line is our cumulative savings. The cumulative savings is just the savings that accumulates day after day after day based on the energy use. And so as we're going through this energy program, as things were implemented, you can see over on the right-hand side that our cumulative savings is upwards of $70,000. So this way we can not only quantify exactly what the dollar amount of the savings was, we can quantify what the energy savings, we can give all those juicy numbers to the vested parties that approve the project, the utilities that have incentive dollars online, the accountants that assign the budgets. This gives all the real data to those types of projects to justify things. So again, the predicted minus the actual energy is our total energy savings. So I want to take a minute to go over some of the graphs, some of the information that an EMIS system can provide. So again, we're compiling all this data. It's just a matter of what information in this data is going to be most important to us. Well, we can look at week-over-week comparisons. So we can see on the top graph here, we've got a green line and a blue line. One is this week, the other is the previous week, and we can see how are we doing this week versus the previous week. Now, the lines, of course, are never going to line up perfectly. There may be some hiccups in production. There may be differences in temperature. But what we want to look for is we want to look for anomalies. If there's any big spikes, we want to be able to isolate those and find out what those spikes were. If there's anything that's diverging from the previous week and it's not coming back down, we just want to be able to see from here if there's any big changes that we're not aware of. Same thing looking month over month. You can see these lines line up. What my eye gets drawn to is over about 3/4 of the way over. You can see that green line does diverge from the blue line. And so that's just a red flag in my mind. What happened there? Looks like it came back down, but that's something that's worthy of investigation. You can narrow that down to the exact 15-minute interval of when that happened, and you can start asking questions of your maintenance and technicians and see, was there something that happened here? Maybe it's justified, maybe it's an opportunity. Another opportunity we can look at is submetering. I mentioned if you have some big energy-consuming pieces of equipment, in this case, we've got some compressors that are operating. You may want to submeter those to see how their operation is in comparison to your facility as a whole. So in this case right here, we can see we've got 4 different compressors. Each one of them has a CT on it, so we're measuring amps here. And on the weekend, which is we're showing poor operation on here, we can see the energy or the current on these compressors did come down. The pink one came down a bit, blue one came down a bit. But if we compare that to the following weekend, we can see the following weekend that pink compressor came off completely, and we have much less current, much less power being used. And so just by taking a look at some of the submetering, we can see, well, the prior weekend, we didn't have a proper shutdown. Why not? Did we maybe have weekend production that accounted for that? Or did someone just forget to turn it off before they went home? So again, the more information helps you make decisions moving forward. Other reports that you can get, this is an extremely detailed report. Just shows you some of the power of an EMIS system. But this is a report they might see being sent to a general manager of a facility, somebody that might not be interested in seeing the daily energy use or the minute-by-minute energy use. They want to be able to see, are we saving energy over the long run, and if so, how much? What's the actual dollars associated with that? So without going into a lot of detail on here, just taking a quick look at the top left, this shows you the program to date since when they implemented this EMIS system and the energy savings actions. They've saved 2.7 million kilowatt hours. We've got a total cost savings of $166,000. Average monthly savings, last 3 months percentage. So you've got just about every single number and statistic in here that you can imagine. And then it breaks it down month by month. So you can see which months you're doing better, which months you weren't doing better. And just being able to try to find opportunities that way. There's also on the middle of the graph here, we've got some bar charts of what the energy use for each month was compared to the same month in the previous year, and also compared to the predictive model that was generated for this facility. And then down at the bottom, just some of the raw numbers that go into it. So a report like this may be a little bit overwhelming because it has so much information, but you can certainly pick and choose what pieces of information are the most relevant and get it to the appropriate people. Another type of report that we like to use are heat maps. This heat map here shows you on the dashboard what the week-to-week energy use is, the month-to-month, and the year-to-date, so it kind of gives you a high-level perspective. But then the heat map shows you what your energy use is on an hour-by-hour basis. So if you look on this graph over on the left-hand side, this is each day of the week, starting with Wednesday through Tuesday. And then on the x-axis above, we've got the different hours of the day. So starting at 0 for 12 o'clock on over to 2300 hours. So the heat map shows us for each hour where the most energy was used and where accordingly the least amount of energy was used. And what that can tell us is, just looking at here, you can see on the very top left, the most energy during this week was that top left corner. It was about 1,800 kilowatts. And that was at Wednesday at midnight. Well, what happened Wednesday at midnight? Is that a time when we expect the energy to be that high, or was that an area of opportunity? The least amount of energy used is going to be Sunday there on the 14th hour, about 1,400 kilowatts. That certainly seems reasonable. They probably were shut down on a Sunday. But be able to take a look at this, maybe comparing this to your rate structure for on-peak, off-peak rates, and then seeing this week after week and seeing where those red splotches are to see if that's changing, number one, and if there's an ability to reduce the demand charge or if there's an ability to equalize the load a little bit during those time periods. It just shows you some different opportunities to move forward with. You can also, for facilities that have, or companies that have multiple facilities, you can roll all this data up into general enterprise reporting. So in this case right here, we've got a number of facilities, shows us just at a glance which facilities are doing well on our week-to-week, month-to-date, year-to-date. Looking at our month-to-date, we can see that the top facility, their Burnside, is down 47% energy, so we know they're doing really well. The bottom facility there, their energy is up 19%. So anything that's red, red equals bad, green equals good. You can concentrate on which ones are using more energy and try to focus your efforts there. And the bottom part of the graph just shows how much energy each one uses, and the size of each block is directly related to how much energy they're using. So you can see which facilities are your higher energy users, which ones are your lower energy users. And the facilities may be different. This may not be indicative that the Hoyt facility is the most efficient because it's the smallest, or it's using the least amount. It may just be the smallest facility. But it's a good comparison to show you corporate-wide where your energy is going into which facilities. So in summary, an EMIS system alone will not save energy. That's the main point. It is one integral part of a larger energy management system. It needs to be combined with a comprehensive energy management system. An EMIS system provides the information needed to make educated decisions regarding a facility's energy use. That includes a lot of things: energy drivers, demand, scheduling, tracking energy savings and actionable items, baselining, budgeting, predictive energy use, reporting and accountability, and then catching backsliding events and reversing negative trends. A lot of times it's hard to see when things are going wrong and be able to catch that and reverse them and put yourself back on course. So with that, I thank you very much, and I hope you found this informative.